The truck stopped at the edge of the forest before dawn. Inside 4 wooden crates, 4 wolves paced without making a sound. Tomasz Wierzbicki had waited 6 years for this single morning. Frost covered the pine needles in a thin layer of glass. Nobody in the nearby village believed this plan would ever work. The forest behind him had been declared ecologically dead a decade earlier. No birdsong, no rustling deer, only wind through empty branches. He knelt beside the first crate and unlatched the heavy door. A gray female stepped out and vanished into the tree line. 3 more wolves followed within seconds, swallowed by dark trees. Tomasz stood alone, listening to a silence that felt different now. He had no way of knowing if they would survive winter. Local farmers had already signed petitions demanding the project be stopped. Government officials gave him 18 months before pulling all funding. Everything depended on 4 animals nobody had asked to be there. Cameras strapped to nearby trees caught only shadows moving through fog. 1 wolf paused at the ridge and looked back toward him. Then she turned and disappeared into land that had forgotten wolves. He drove home in the dark, replaying the release in his mind. Sleep did not come easily that first night after they left. The forest had lost its last wolf nearly 90 years before. A trapper shot the final one in the winter of 1936. Since then, deer numbers multiplied far beyond what the land could hold. Young trees never grew past a few inches before hungry mouths found them. Streams ran wide and shallow, stripped bare of any shading cover. Scientists had a term for what happens when top predators vanish. They called it a forest frozen inside a permanent silent decline. By the time Tomasz arrived, the numbers told their own story. 900 deer per square mile grazed on almost nothing left. Oak seedlings had a survival rate under 2% most years. Beavers had abandoned the river system entirely by the late 1990s. Fish populations dropped as water warmed without any tree cover left. Foresters tried fencing off saplings, but deer found every single gap. Hunters tried culling herds, but births outpaced every bullet fired. Nothing tried in 3 decades slowed the decline in any real way. A biologist named Elżbieta Kowalska proposed something nobody wanted to hear. Bring back the one animal capable of changing deer behavior itself. Wolves change deer behavior far beyond simple predation, she explained. They change where deer choose to eat and how long they stay. That single idea would take 4 more years to become policy. Farmers packed town halls, worried about livestock and their children's safety. One man stood holding a photo of his grandfather's dead sheep. Kowalska did not dismiss the fear sitting inside that crowded room. She showed data from regions where wolves and farms coexisted for decades. Compensation programs existed, guard dogs worked, and attacks stayed extremely rare. Still, the vote nearly failed by a single council member's decision. It passed only after a compromise limited the release to 4 wolves. 4 animals, tracked constantly, removed immediately if anything went wrong. Tomasz was chosen to lead the ground team monitoring their movements. He had spent a decade studying wolves across the Carpathian Mountains. This project felt personal, tied to land he grew up walking. His grandfather once told him stories about wolves crossing this same ridge. Those stories had stopped by the time his own father was born. Now 4 wolves fitted with collars carried that history forward again. Each collar sent a location signal every 4 hours by satellite. Tomasz checked the incoming data before sunrise the morning after release. All 4 wolves had moved in roughly the same direction overnight. They stayed together, which biologists considered the first genuinely good sign. Wolves separated from their pack rarely survive more than a few weeks. By the 2nd week, the pack had covered nearly 40 kilometers. They avoided roads, avoided farms, and stayed deep inside forest cover. The first confirmed kill came on day 12, a young roe deer. Tomasz found the site by following coordinates from the morning's collar signal. Bones, hide, and a scattering of tracks told him most of the story. He photographed the site the way he had trained for years to do. Distance from cover, angle of approach, and how long the pack fed there. This single kill meant little on its own, statistically speaking. It mattered because it proved the pack could hunt without human assistance. No supplemental feeding had been planned, and none had been needed yet. Kowalska logged it as data point 1 in a growing field folder. Then, on day 19, one caller stopped transmitting overnight without warning. Tomasz drove out at first light, fearing the worst possible outcome. He found the youngest male tangled in an old, forgotten snare. The wolf had died hours earlier, likely from exhaustion and blood loss. 3 wolves remained, and public criticism arrived within the same afternoon. A local newspaper ran the headline, "Doomed Experiment Claims First Victim." Kowalska defended the program on regional television that same evening. "One loss in 19 days does not define a multi-year project," she said. Tomasz spent that winter tracking the remaining 3 through deep snow. He recorded their movements, their kills, and every den site used. By February, the 3 wolves had claimed a territory of 80 square kilometers. They killed deer roughly once every 4 to 5 days. Each kill site told him something the reports alone never could. Deer carcasses appeared mostly along forest edges, not deep inside cover. The surviving deer began avoiding those open, exposed feeding areas entirely. Biologists call this shift the landscape of fear, and it works fast. Deer that once grazed anywhere now clustered near thick, defensible brush. Open meadows sat untouched by spring for the first time in years. Stream banks stripped bare for decades finally had a season to rest. By April, Tomasz noticed something he had not expected so soon. Willow shoots along the riverbank grew past 6 inches in one season. He photographed the same stretch of stream every month without exception. April showed bare mud, and May showed the first green shoots. By July, willow stands stood nearly 2 feet tall along both banks. Aspen saplings followed the same pattern in shaded ground nearby. Kowalska called it the fastest vegetation response she had ever documented. Local skeptics remained unconvinced, calling 3 willow bushes meaningless evidence. Around that time, the team started a small public naming initiative. Each collared wolf received a number for records and a public name. The first release female became known locally as Sosna, meaning pine tree. Children submitted name suggestions through a box at the village school. Tomasz admits the naming felt unscientific at first, almost uncomfortable to allow. Kowalska disagreed, arguing that names build attention where numbers rarely do. A local radio station began giving short updates on Sosna's movements. People started asking about her the way neighbors ask about each other. That shift in language changed how residents discussed the project at home. Wolves stopped being an abstract policy and became specific animals with names. Tomasz kept collecting data, aware one summer proves very little alone. A regional television crew filmed the willow stands for a segment. The farmer who lost his grandfather's sheep refused to appear on camera. He told a reporter privately that he still wanted the wolves gone. Kowalska used the footage anyway, pairing it with population survey numbers. The following spring, the pack produced its first litter of pups. 5 pups were born inside a den dug beneath an old pine root. Tomasz watched from a distance, careful never to approach the site. He used a thermal camera to count movement without disturbing the den. The pack now numbered 8 wolves split across 2 hunting groups. That split happened gradually, not as a single dramatic departure. 2 young males began ranging farther east during their second winter. By spring, they had stopped returning to the original den entirely. Tomasz tracked their new territory using the same collar signals as before. They had claimed roughly 30 square kilometers along a separate river valley. A second den appeared there the following year, confirming a breeding pair. Local officials in that district had to update their own compensation plans. Nobody there had expected wolves to arrive on their own so soon. The original pack, now smaller, adjusted its hunting range within a season. Deer avoidance patterns grew stronger as pup rearing demanded steady hunting pressure. Riverbank growth kept expanding, and beavers noticed before most humans did. A single beaver dam appeared 11 kilometers upstream that same autumn. Beavers had not built there in over 20 documented years. Their dam slowed water flow, creating the first new wetland pocket. That wetland attracted herons within its first 6 months of existing. Frog populations followed within a year, drawn by shallow standing water. Songbirds returned to willow thickets that offered cover deer once destroyed. A university team counted 17 new bird species across 3 seasons. Fish populations in cooler, shaded streams began recovering their former numbers. Trout, absent from surveys since 2003, reappeared in downstream sampling nets. None of this happened because wolves hunted fish or built dams. It happened because deer stopped eating everything the moment predators returned. A second beaver dam appeared the following spring, further downstream still. Otters were spotted near that dam for the first recorded time. Local naturalists began keeping informal logs of every new sighting. What had been a quiet decline turned into a quiet recovery. Farmers who once opposed the project watched their own land shift too. Fewer deer meant fewer crop losses along fields bordering the forest. One farmer, previously among the loudest critics, changed his position publicly. He told a reporter the wolves had done what fences never managed. Compensation claims for livestock losses stayed below early predictions each year. Guard dogs and simple fencing prevented nearly all reported wolf encounters. Attacks on livestock totaled 4 incidents across 5 full years. Tourism offices noticed visitor numbers rising for an unexpected reason. People wanted guided tours hoping to hear wolves howling at dusk. A small guest house near the forest doubled its bookings within 2 seasons. Local guides trained specifically to lead wildlife tracking walks nearby. Money that once left the region now stayed within nearby villages. A poacher was caught setting snares near the pack's second den site. Rangers had been watching the area after finding fresh trap wire. The case became the first prosecuted wolf poaching charge in the region. It sent a signal that the animals now had legal protection behind them. The trial took place in a small regional courthouse the following winter. The poacher argued the snares were meant for foxes, not wolves. Evidence showed the wire gauge matched wolf-sized trap patterns exactly. A wildlife lawyer representing the state presented photographs from ranger patrols. The judge fined him and suspended his hunting license for 3 years. Local hunters largely stayed quiet, unwilling to defend the case publicly. Kowalska attended every session, taking notes for future policy arguments. She later used the ruling to push for stronger poaching penalties nationwide. Parliament adopted stricter wolf protection laws less than 2 years later. Tomasz says the case mattered more than any single vegetation survey. Laws only work, he says, when someone is willing to enforce them. The rangers who found the snare became local minor celebrities briefly. They insisted they were only doing their assigned patrol work that week. By spring, no new snares were reported anywhere near pack territory. Rangers still walked that stretch of forest twice a month. A different test arrived in year 3, unrelated to people entirely. One of the pack's founding females developed patchy fur along her hindquarters. Tomasz spotted it through a spotting scope during a routine morning check. Manje had wiped out entire wolf populations in other parts of Europe. He notified Kowalska immediately, and both feared the worst for the pack. A wildlife veterinarian reviewed weeks of trail camera footage before responding. She confirmed early-stage mange, treatable if caught before it spread further. The team faced a choice between trapping her or watching from a distance. Trapping risked stress that could push a wild wolf away from her pups. They chose to monitor closely and prepare treated bait as a backup plan. Through late summer, the patch neither spread further nor fully healed. By autumn, camera traps showed new fur growing back along her spine. Her body had fought off the infection without any direct human contact. Kowalska called it proof that a healthy population can absorb real setbacks. The mange scare never made it into the regional newspaper that year. Tomasz kept the incident in his field notes, unwilling to invite more panic. Looking back, he says it taught him patience mattered more than intervention. That lesson shaped how the team handled every difficult decision afterward. By year 4, the team began using AI-assisted camera trap software. The software flagged wolf sightings automatically instead of requiring manual review. That change cut analysis time from days down to a few hours. Tomasz remained skeptical of new technology at first, preferring manual counts. He compared software results against his own notes for an entire season. The two methods agreed on nearly every sighting logged that year. After that, he trusted the system enough to rely on it daily. Kowalska used the freed-up time to expand vegetation surveys further downstream. New survey points revealed recovery patterns nobody had measured before. Willow growth extended nearly 3 kilometers beyond the original study area. That expansion surprised even Kowalska, who expected slower spread than this. She admitted the models had underestimated how fast a river responds. Updated projections now guide similar projects being planned in other regions. None of those projections existed when Tomasz first opened that crate. By year 5, the wolf population had grown to 14 individuals. Two separate packs now held territory across roughly 200 square kilometers. Deer density had dropped to a level foresters considered genuinely sustainable. Oak seedling survival climbed from 2% to nearly 40%. Streams that once ran wide and shallow narrowed under new tree cover. Water temperatures dropped enough to support species absent for 2 decades. A dry summer in year 4 tested whether the recovery would hold. Rivers ran lower than usual, and some willow stands browned early. By the following spring, growth resumed almost exactly where it stopped. A flood hit the valley 2 years after the drought, testing things differently. Heavy spring rain pushed the river over its banks for 4 days. Older residents worried the new beaver dams would collapse under the pressure. Instead, the wetlands absorbed much of the surge before it reached the village. Downstream flooding was noticeably lower than during a similar storm a decade earlier. An engineer hired to assess the damage credited the wetland system directly. Beaver dams, she noted, slow water release the way concrete barriers cannot. The village council that once opposed the wolves thanked the beavers instead. Nobody mentioned that the beavers were there because of the wolves. Tomasz noticed the omission and chose not to correct anyone publicly. Kowalska published findings comparing pre-release data against 5 years of results. The forest she described bore little resemblance to the one from 2018. Her paper drew attention from researchers studying similar declines elsewhere in Europe. A delegation from Scotland arrived that autumn to study the monitoring methods used. They were exploring a similar proposal for a forest in the highlands. A separate team from Romania visited the following spring for the same reason. Both groups spent days walking the same transects Tomasz had walked for years. They asked about collar frequency, deer counts, and farmer dispute handling. Tomasz found himself repeating advice he once needed from someone else entirely. Start small, track everything, and let the data convince people, he said. The Scottish proposal moved forward 2 years later, using a similar staged approach. Kowalska was invited to speak at a conference in Edinburgh about the results. She brought willow growth photographs instead of slides full of raw statistics. A single image of bare mud beside new willow needed no caption. Attendees asked more questions about that photograph than about anything else she presented. The project, once dismissed as reckless by local officials, became a reference case. Universities across 3 countries now cite the forest in wolf reintroduction research. None of that recognition changed what happened on the ground day to day. Tomasz still checked traps, logged tracks, and drove the same forest roads. A film crew from a national broadcaster spent a week following the pack. They caught footage of pups play fighting near the den at dusk. That footage aired months later and reached far beyond the region itself. The journalist who wrote Doomed Experiment Claims First Victim requested a follow-up. Piotr Novak had covered the project's early failures without much sympathy. He expected another routine story about a struggling government-funded conservation effort. Instead, Tomasz walked him along the river where willow now grew thick. Novak asked to see the exact spot photographed bare 5 years earlier. Standing there, he admitted the scene looked nothing like his memory. His follow-up article ran under a far different headline than his first. He never called the outcome inevitable, only unexpected given how it began. That distinction mattered to Tomasz more than any praise the article contained. Visitors began arriving from other countries hoping to hear a single howl. On the 10th anniversary, the village held a small gathering near the river. Nobody had planned a formal ceremony when the project first began years ago. Kowalska stood beside the same stretch of bank photographed bare in 2019. Willow now grew taller than most of the children standing near it. A local schoolteacher had brought her class to see the wolves' territory firsthand. None of the students had ever known a forest without predators in it. For them, wolves nearby was simply an ordinary fact about where they lived. Tomas found that detail more meaningful than any published paper or award. A regional environmental board named the River Restoration Project of the Decade. The award recognized the entire team, not any single researcher's individual effort. Kowalska insisted the wolves themselves deserved equal credit for the outcome. They did not restore the forest through intention, only through simple behavior. That distinction became central to how she described the project afterward. Predators do not plan ecosystems, she said. They simply change what prey do. Everything else follows from that single shift in behavior over time. By then, 3 additional regions across the country were planning similar releases. Officials from each region visited the forest before finalizing their own proposals. Tomas walked them through the same ridge, the same river, the same records. He no longer needed to convince anyone that the approach could work. The data from 10 years of tracking did that convincing on its own. A national wildlife agency began funding a monitoring network built on this model. 12 sites across the country now feed data into the same shared database. Researchers compared deer density, vegetation growth, and predator movement across every site. The forest where it started remains the network's most complete data set. Every willow measurement, every collar signal, traces back to that first cold morning. Pyotr Novak still writes occasional updates for the regional paper each spring. His most recent piece focused on the schoolteacher's class visiting the riverbank. He ended it without declaring the project finished, only still unfolding. The forest, he wrote, keeps changing in ways nobody predicted at the start. Tomas still walks the same ridge where he opened that first crate. He no longer needs radio collars to know wolves are nearby. Fresh tracks in mud tell him enough most mornings before sunrise. Sosna is gone now, but her descendants still hold that same territory. She lived 9 years, longer than most wild wolves typically survive. Her final litter was tracked by a granddaughter of the same veterinarian. That continuity across 2 generations of researchers was never planned deliberately. It happened because the project outlasted the people who once doubted it. Howls carry across the valley some evenings, answered from another ridge. The village that once demanded the project end now sells wolf-themed souvenirs. Children who grew up fearing wolves now study them in school projects. His grandfather's old stories no longer sound like something from the past. They sound instead like a description of the forest as it exists today. He sometimes brings visiting researchers to the exact spot the crates opened. There is nothing marked there, no plaque, no sign, no fence. Tomas prefers it that way, worried a monument would flatten the story. The forest itself is the only record he trusts to stay accurate. Kowalska retired 2 years ago, but still visits the site each spring. She says the willow stands along the river are her proudest measurement. Tomas took over her role, training a new generation of trackers. One of them is the farmer's daughter, the boy who once refused interviews. She asked to join after seeing wolf tracks on her own land. Her father still will not say the word wolf without some hesitation. He no longer signs petitions, and that change means more than words. His daughter now knows the forest better than he ever did. She plans to study wildlife biology once she finishes secondary school. Tomas says he sees a little of his younger self in her. Neither of them expected a forest to teach them anything about people. Some evenings, Tomas brings his own daughter along on the walk. She is 7 now, old enough to recognize a fresh paw print. He points out the difference between a dog track and a wolf's. She already knows it better than most adults in the village. One day she asked him why people were ever afraid of them. He did not have a simple answer ready for her that evening. Fear made sense back when nobody understood what wolves actually needed. Understanding came slowly, through failed fences, dead sheep, and years of data. It came through willow shoots, beaver dams, and a river running cooler. None of it happened quickly, and none of it happened by accident. The forest remembers none of the arguments that nearly stopped it. 4 wolves walked into that forest not knowing what they would find. What they found was land waiting, in its own way, to heal. Nobody signed up to save an entire forest with 4 animals. They signed up to see if 4 wolves could simply survive. The forest did the rest on its own, one season at a time.